Hello friends, welcome to our channel. In this lecture, I would like to solve some simple examples which was based on the previous concept formula. So see here, what is given in the example, a short column 400 mm by 400 mm. So here, take down given data. So they will given 400 by 400 mm. So both dimensions are same, that is square column. Okay, based on this we can know square column, that is square column is reinforced with 4 numbers of 25 mm dia. So reinforcement is given as 4 numbers of 25 mm dia. Find the axial factored load that the column can carry. So axial factored load is P. Factored load means which is denoted with U. So you can find out that one. So the materials will be given. M20 grade concrete will be 20 Newton per mm square, which is FCK, and F5 will be 415 Newton per mm square. So what is the formula I told you in the last concept for finding the axially loaded short columns? That is PU is equal to 0.4 FCK AC plus 0.67 F5 ASC. So this formula there is in your code book also. So which was already given in our code book. So already I told you what is FCK. FCK is the characteristic compressive strength of the concrete, that is 0.4 into 20 in place of FCK 20, and here your unknown is AC plus 0.67 Fy. In place of Fy it will be 415. And what about this ASC? So here 4 number of bars is given. ASC is the area of the steel and AC is the area of the concrete. So therefore your area of the steel will be equal to 4 bars means 4 into dia means 5d square by 4. 4 bars of 24, 5 dia means 4 into pi d square by 4, like n into pi d square by 4. So if you simplify that one, you will get your area of the steel will be 1963.5. So that is 1963.5 mm square. So you can substitute area of the steel here directly, that is 1963.5. And what about this area of the concrete? So if you observe clearly, your gross area, overall area will be equal to area of the concrete plus area of the steel. So for example, what I am telling means, so this is a square column. Already we know that is a square column because of the dimensions what already given here, that is 400 by 400 in mm. So here we have to produce reinforcement also for that one. So maybe some assumes the reinforcement also like this, 4 bars of some 25 dia. So all balls are in same dia only. So you don't know area of the concrete. So then take down, we know area of gross area, that is 400 by 400. And again if I am sending this one this side, that is 1963.5 equal to area of the concrete. So you please simplify that one, you will get area of the concrete will be equal to around 158036.5 in mm square. So you know the value of area of the concrete and this one. So then just substitute these two values here. Pu equal to 0.4 20 into area of the concrete is 158036.5 plus 0.6 into 415 into 1963.5. Then you will get axial factored load directly. So that one will be equal to 1810.24 into 10 to the power of 3 newtons. If you want to convert, that one will be in terms of kilonewton, directly take down 1810.24 in terms of kilonewton. So this is the procedure for finding axial loads based on the given formula. Okay, then in the same way, so what is the difference between square column and rectangular column? So the dimensions will be somewhat different, like 400 by 600, you just take down as it is. But whenever circular column is given, what you have to do means entire data will be same. See here, according to the given data, so here circular column of diameter will be given, that is 400 mm, with area of the steel which is given as 6 numbers of 16 mm dia. So take down 6 into pi d square by 4. If you simplify this one, directly you will get 1206.4 mm square. Then what are the requirements? So FCK is 20 Newton per mm square and Fy is 415 Newton per mm square. So then find the axial factored load according to the given question. So already we people know the formula. Just substitute Pu is equal to 0.4 FCK AC plus 0.67 Fy ASC. So already we people know that gross area will be equal to area of the steel plus area of the concrete. So already I told you here. So gross area means entire column area. So this total, this lengthwise and widthwise total area. In that what it will be covered? Area of the concrete also covered, all these things, and area of the steel also covered. So therefore overall gross area will be equal to area of the concrete plus area of the steel. So here already we people know area of the steel value, which is 1206. Then gross area will be equal to diameter. In terms of diameter means, if you want area, pi d square by 4, and I am sending this area of the steel this side, then that one will be equal to 1206.4. you will get directly AC value. That AC value will be equal to 124457.3 mm square. So if you substitute all the values one by one here, 0.4 into 20 into area of the concrete will be 124457.3 plus 0.67 into 415 into area of the steel will be 1206.4. If substitute all the values, directly you will get the value, that one 1331.1 into 10 to the power of 3 newtons. So if you want in kilonewtons, take down divided by 10 to the power of 3, which is in terms of kilonewton. So this is the procedure for finding different columns like circular column, rectangular column, square columns. Just I am showing the basic example in what way you have to find out the axial factored load when other values will be given in the data. So in the next class I will explain one of the design which is based on the square column. I hope you understand this lecture. Thank you so much for watching this video.